this example from previous meeting, which is equal to 1. And this is also the solution to this I have illustrated in previous video. So this is of the form infinity over infinity. And we have of the form also infinity over infinity. So you have to take note that if your function, if you are going to evaluate a function that is of this form, then L'Hopital's rule may be used. So let's take up ng function. Take note, for the first term, 1 over e to the 0 minus 1 will give you 1 over, this is definitely not 1 over 0, but if you have a value that gets smaller and smaller, then this approaches infinity. And for the second term, you have 1 over 0, or not really 0, kasi wala naman tayong divisor na 0, but then again, it approaches 0. Okay, either from the positive side or from the negative side. But this value here gets very, very small. So again, 1 divided by a very, very small value approaches infinity. Becomes very huge. So this is definitely infinity minus infinity. So what we're going to do, as I have illustrated in previous example, we're going to get the LCD. So after getting the LCD, you verify. Because our goal from this indeterminate form, we have to transform it into either 0 over 0 or infinity over infinity, so that we can apply LHR. So let's verify if this is indeed 0 over 0 or pwede ring infinity over infinity. If we are going to substitute the value of x, so this will be 0 minus e to the 0 plus 1 divided by 0. Definitely, the denominator is 0. So this should be 1, negative 1. So this is of the form 0 over 0. Now that you have verified that for 0, you're going to apply LHR. What's the derivative of x minus e to the x plus 1? E to the x plus 0. Okay? What's the derivative of our denominator? X times e to the x minus 1. So the derivative of this, we use product rule. As e is cx, derivative of e to the x minus 1 is e to the x. Plus, derivative ng x is 1 times, as is naman tong grouping na e to the x minus 1. So if we simplify this. And so, after applying L'Hopital's rule, we verify once again kung nakaahon na tayo sa pagiging indeterminate nitong form na to. So we write our new expression, which is now in terms of the derivative. So 1 minus, and the derivative of the denominator is x e to the x. Applying the limit, we have 1 minus e to the 0. But obviously, this is 1. So we have definitely 0 for the numerator. We have 0 times e to the 0 plus e to the 0 minus 1. So our denominator is still 0 over 0. So how many times have we applied our LHR? Once pa lang. Okay. And after applying the LHR, still our expression is an indeterminate form. We apply LHR second time. So we get the derivative of 1 minus e to the x. Derivative of that is negative e to the x. What's the derivative of our, so we have here a power rule, a product rule. So we have derivative of x is 1 times e to the x plus x times e to the x. That's for the first term, derivative. Plus derivative of e to the x is still e to the x. Derivative of negative 1 is 0. Which means we have here 2e to the x plus x e to the x. Still 0 over 0. When we apply, substitute the value of x equals 0 to all the x's. So we have 2e to the 0 plus, definitely this is 0. Which means we have negative 1 over, this is 1. So the answer is negative 1/2. So now we know that the original expression, which is 1 over e to the x as x approaches 0 is equal to negative. The third type of, you apply the value of infinity, so you will know what kind of indeterminate form this one is. We have 1 plus infinity. Definitely this is infinity. Kasi isang napakalaking number, dadagdagan mo ng isa. E di infinity pa rin yun. Raised to 1 over infinity. This will have infinity. Ano yung 1 over infinity? What is a constant divided by a very, very huge number? The answer is, what's the answer of this class?
Undefined po.
And,
0 po.
0. Yes. Very good. Okay. Nakakasabay kayo. So we have infinity raised to 0. This is one form of an indeterminate. So what we're going to do, because this is not 0 over 0, nor is it infinity over infinity. So what we're going to do, we let y be equal to 1 plus x raised to 1 over x. And then we get ln of both sides. So ln of y is equal to ln of 1 plus x raised to 1 over x. But we can write this as 1 over x, ln of 1 plus x. Now, to have a quotient form of an expression, we go back to our limit and rewrite this one in the form ln of 1 plus x over x. And so, what do you think is the answer? Infinity over infinity or 0 over 0? Obviously, this is infinity over infinity. So now you have reason to apply LHR. Derivative of that is 1 over 1 plus x times the derivative of 1 plus x, which is 1. So there's no need to write 1 here. There's no need to write for that 1. What's the derivative of our denominator? Simulative. As x approaches infinity, we have 1 over 1 plus x over 1. Or you can write that one as the limit of 1 over 1 plus x. If you substitute the value of infinity, of course, definitely this is not 0 over 0 anymore because we have a numerator that's obviously equal to 1. How about denominator? It is equal to What is this, class? This is 1 over
Infinity.
infinity. Okay? So, we have 1 over infinity, and that is equal to what?
0.
0. Yun. So, the answer is 0. For this limit, we're just getting the right side of our equation in this part here, because we have ln of y, which means that this value here is equal to 0. Y equals 0, because this is 0. So, solving for y, we have a value, get the e of both sides. So, we have e to the ln of y equals e to the 0. That means you have y equals 1. So, we now have an answer to our limit. Okay? Minus x. As x approaches 1. So if we verify this, this is 1 raised to 1 over this value, ano yan, becomes very, very small. Kasi when your x approaches 1, either from the left side or from the right side, anong mangyari dito sa 1 over 1 minus x? 'Di ba, yung difference nito becomes very, very small. This difference becomes very, very small. When you take the other side, we have a value of, let's say, 0.9999. Still, it approaches 1, but from the left. So what's the difference of 1 minus 0.9999? Ito, may negative pala yan. Pero ito will take positive values. Diba, class? Guys? 1 minus 0.9999, meaning it approaches the value of 1. So the difference would be 0.00001, right? Okay. Value for this expression. What's the value? It approaches what?
Infinity.
Infinity. Okay, nakuha nyo yung logical thinking na yan. So that's 1 raised to infinity. So it is among those indeterminate form. So what we're going to do, the same process. So we let y be equal to x raised to 1 over 1 minus x. And then we get the ln of both sides. So we have ln of y equals ln of x raised to 1 over 1 minus x. But we can write this as 1 over 1 minus x times ln of x using the property of logarithm. And so we can rewrite our new expression into ln of x divided by 1 minus x. Verify if it is 0. Is this 0 over 0 or infinity over infinity?
Infinity over infinity.
Okay, so this is of the form infinity over infinity. Ano ba? Ano sa palagay? Tama ba yan? What is ln of, as x approaches 1, what is ln of 0.99? This ln of 0. So going back, we have 0 over 0. Now, we can derive because we can apply L'Hopital's rule. What's the derivative of ln of x? Derivative of ln of x is 1 over x. Derivative ng 1 minus x is equal to negative 1. And so you rewrite the limit as x approaches 1 of 1 over x over negative 1. Or you may also rewrite this, simplify, is what? The answer is
Negative 1 po, ma'am.
negative 1. Okay, very good. So the answer is negative 1, but then hindi pa yan yung final answer natin. Kagaya ng ginawa natin kanina, we have arrived at a value of 0, but we have to go back because we have let this be equal to y. So you now have y equals ln, by the way. ln of y is negative 1. And so, get the e of both sides. So we now have e to the ln of y is, by the way, equal to y. And you have e limit. This one. That is equal to 1 over e. So not all will have an answer na 0, 1, infinity. You could have answers like the first. Okay, so when you substitute the value of x as 0, this is 0 raised to 0. So what we're going to do again, we let y be equal to x sine of x. Ganun pa din, no? Then get the ln of both sides. So ln of y equals ln of x sine of x. And then using the law of logarithm, this is sine of x times ln of. If you say write this in as an expression with limit, meron tayo ditong anong value natin? An indeterminate form. Initially, ito yun. Tapos, na-reduce natin to this. Pero hindi pa yan pwede kasi we have to rewrite it because you can only apply L'Hopital's rule if it is of the form 0 over 0 or infinity over infinity. So you have two options. One is you write this in the form sine of x over 1 over ln of x. Quotient form. You have numerator, you have denominator. Or you may write this as yung ln of x over 1 over sine of x. Which one is a better way of arriving at a solution? Which one will give you a more direct form or process of arriving at an answer? Which one will get more complicated as you derive it? You have to identify because you may get lost. Which one?
Two po, ma'am.
2. Why? That's correct. Pero why did you say 2? So, yeah. Because makikita mo na medyo magiging simpler siya. Imagine you, class. Pag ito, i-derive mo yan. That definitely brings you to quotient rule. Low derivative of high, which is 0, minus high, which is 1. Derivative ng low is 1 over x over low squared. Diba? Sa denominator lang yan, ah. So, mas nagiging complicated siya. Okay? Whereas, this 1 over sine of x, you can actually write that as cosecant of x. What is the derivative of cosecant of x? We have a straightforward answer to that. So what's the derivative of ln of x? And that's just 1 over x. What's the derivative of cosecant of x?
Negative cosecant x cotangent x.
Okay. Negative cosecant of x cotangent of x. So now, nakuha mo na yan, i-rewrite mo na ngayon. So after applying L'Hopital's rule, I have a new expression and hoping that, crossing your fingers. Now when you apply the limit, you will have an answer. Hindi siya yung indeterminate form pa rin. So you have cosecotangent of x. Actually, you can simplify this. Pwede natin itong, diba, we know 1 over sine is cosecant. 1 over cosine is secant. Okay? 1 over tangent, cotangent. So, tingnan natin. Itong 1 over x, pwede kong isulat yan sa baba. Then I have a negative sign sa taas. It's the same. Tapos yung cosecant of x, perhaps I can write that as 1 over sine of x. Tapos yung cotangent, I can write that as inverse of a tangent. But what is tangent? Sine over cosine. So I can write that as cosine of x over sine. Diba? Mas madali kasi mag-evaluate pagka ganyan. And so, with the use of, okay, so meron tayong negative sign. Itong sign na nasa taas, pwede nating i-simplify ito. You can write negative 1. Still, there is a limit, as x approaches 0 from the positive. So, meron tayo ditong negative 1 over x, tapos cosine of x over sine squared of x.
Paano po nalaman kung hindi na po, kung tutuloy pa po ang
Pag-apply ng
Opo.
L'Hopital's rule.
paano po
Ito yung mga palatandaan para
Okay.
titigil ka na. Dapat, ang denominator mo, ito yon, di ba? Meron kang P over Q. Dapat yung Q na yan should not be equal to 0. Yan ang isa. Pangalawa, dapat hindi na siya indeterminate. So dito, sa part na to, so nire-write natin siya, no? Tapos titingnan mo rin yung argument. So meron na tayong ganyan, 1 over x divided by negative 1. Nire-write natin siya ng 1 over x times, kasi itong negative 1, that's 1 over negative, that's just multiplying by a negative number. So ito na yon. Hindi naman magiging 0 yung ating denominator, kasi ang argument natin is 1. That's why we already have an answer. Numerator natin is not 0. Okay? Wala tayong problema kung magiging numerator ay 0, basta ang denominator hindi lang 0. Kaya balikan natin yung mga examples natin. Saan ba tayo tumigil? Tumigil tayo dito kasi meron na tayong numerator na wait, this is where we did not stop here. Saan tayo? Kasi ito 0 over 0 pa rin, tapos nag-derive na tayo ngayon. Pag-derive natin sa numerator, hindi na siya 0 kasi e to the x na lang. Hindi, mayroon tayong numerator na may value na talaga. Pag i-apply mo yung x equals 0, mayroon tayong e to the 0, which is negative 1. So wala tayong 0 doon sa numerator. How about denominator? Makita mo yung denominator natin when you apply the value of 0 to x. Meron tayong 2 raised times e to the 0, which is 1. Ito, 0 to. Pero okay lang, kasi plus naman yan eh. So, meron ka nang nakikita ngayong sagot. Kaya ka tumigil na. Per 4, hindi pa tayo tumitigil. Una, na-evaluate natin siya dito. Ito yung first natin. Pagkatapos, gumamit tayo ng paraan na ito, na-convert natin siya to this form. So, ito yung second step. And then, we aim to rewrite this na magiging 0 over 0. Kasi hindi naman lumabas na kagaya nito na pagkuha mo nitong step na to, meron ka kaagad in rational or in P over Q form, ng quotient form. Ito kasi multiplication. So, meron tayong option ngayon, kaya nagbigay ako sa inyo ng option. O, saan kayo? Itong number 1 o number 2? Sabi nyo, mas okay yung number 2. Kaya, yan ang ginamit nating approach. Meron na tayo ngayong, nung ating na verify siya, meron tayong infinity over, 0. 0 over 0 ang nakuha natin. Tama ba? 0 over 0. Yes, ln of x. Infinity pala. Infinity over itong form na to. Yan. So, that is of the form infinity over infinity. So, infinity over infinity ito. Kaya, dahil gano'n na yung form niya, magde-derive ka na ngayon. So, derivative of numerator, derivative of the denominator. Pagka nakuha mo yan, sulat mo naman ulit. Ito na naman yung bagong expression niya. So, nakailang bihis ka ngayon ng expression, di ba? So, una, 1, 2. Tapos, nagsulat tayo nito, 3. Okay? Tapos, nag-derive tayo. Ito na naman yung step 4. Medyo mahaba, no? And then, 1, 2, 3, 4. So, pagkatapos ng pag-derive, test it again. Nag-test tayo kung hindi na ba siya indeterminate. Okay, so, kinuha natin yung, bago tayo mag-test, tiningnan muna natin, teka lang, pwede siguro ma-rewrite ito. Kasi, medyo para sa akin gusto ko kasing i-rewrite ito in the form of sine over cosine dahil, well, kung gagamit ka ng calculator, pwede naman, ma-verify mo naman na anong magiging form nito. Kaya ako nag-opt dito dahil gusto kong makita visually without using calculator kung ano ang magiging form nito. Is it 0 over 0 still or infinity over infinity? Bago ako mag-apply ng LHR. Kasi dito, kailangan mo munang i-verify eh. Now, looking at this, makita mo, 1 over 0. Diba? Ano magiging sagot mo dyan? 1 divided by x, wherein x gets very, very small. Diba? Infinity yan. Tapos ito naman, ano kaya ang sagot dito? Kasi ito, 1 over sine. Ito, cosine over sine. So, may nakita na ako ditong infinity over infinity pala. Infinity over infinity. So, still, it is indeterminate. Kaya, isulat natin para magiging, kasi ang dami ng gulo. Magulo na siya. So, ito, the limit as x approaches 0 of this. 1 over x whole over negative cosecant of x, cotangent of x. Okay. How are you going to verify that this is no longer of form 0 over 0 or no longer infinity over infinity? How are you going to verify? You can substitute directly. Okay? What is 1 over x? It's the limit as x approaches 0 from the positive, kasi may positive pala tayo dyan. From the positive side. Ano tong value na to? Anong value niya? What is the value when x gets infinity? Tandaan niyo yan. Tandaan niyo palagi yan. Infinity. Pero yung denominator, medyo kailangan mo pa siyang i-rewrite. Or nasa inyo. What is the limit as x approaches 0 from the positive of this negative? Ano kayang value niya? Para malaman natin kung 0/0 ba siya or infinity over infinity. Baka malay mo may value pala. Malay mo hindi 0. Or malay mo hindi infinity. Diba mahirap i-verify? Kung may calculator ka, madali. Pero kung wala, class, ano yung sagot dyan? As your x approaches 0 from the positive side. From the positive. What happened to this cosecant as your x becomes very, very small? As the angle becomes very, very small, what happens to this value? Yan, mayroon tayong denominator na sine squared. Wala tayong problema sa numerator dito sa, ito lang ha, we're evaluating this. Definitely this is approaches the value of 1. Pero ito approaches the value of 0. Diba class? So parang 1 over approaching a very, very small value. Ba infinity yan? Kuha nyo? So infinity over infinity yan. Now tanong, ma'am, kailan na kami mag-stop? Wala bang paraan dyan? Now, you have to remember, if you deal with trigonometric functions, meron pa tayong isang paraan para magamit natin. Baka lang. This also works if you have a limit of x over sine of x. That is also equal to 1. Hindi lang sine x over x, kundi pati yung reciprocal niya, it is still equal to 1. May proof tayo dyan. So, bago kayo mag-proceed na mag-apply ng Hopital's rule, the second time, kasi naka-first time na tayo, the second time, bago nyo i-apply yan, tingnan nyo muna, baka pwede nating magamit yung sine alpha or x over x. Or ito, kasi both of this is 1. If we rewrite our limit as x approaches 0 from the, ito, rewrite natin ito. Yung x nasa baba. Yung cosecant, so ilagay natin yung negative dyan, is 1 over sine of x. Tapos, meron tayong cotangent na cosine of x over sine. Okay? Ito class, that is already equal to 1. Or you could write the limit as x approaches 0 from the positive side of sine. Pwede kasi natin gawing reciprocal yan kasi nasa baba siya, no? Nasa baba siya, nasa denominator siya. Kaya meron tayong expression sa denominator na x over sine of x. Meron din tayong cosine of x over sine of x. Tapos all over -1 yan, di ba? Kaya pagka gawin natin multiplication yan, kunin natin yung reciprocal sa baba para maisulat natin siya sa taas. Kaya magiging sine of x over x yan times sine of x over cosine of x. Nasundan niyo. Tapos may negative tayo kasi ito yon. Yan na siya. Right, guys? But this is 1. And if we are going to substitute the value of 0 to this one, anong magiging sagot natin? Kasi if this is 1, ito, ano to? What is sine of x as x approaches 0 from the positive side? This approaches the value of ano class?
0.
0. How about denominator? Approaches the value of
1.
1. Very good. So therefore, meron tayong 0 divided by 1. Indeterminate pa ba yan? Indeterminate pa po. Ha? Alin?
0 po.
So the answer is 0. Yan pala eh. So the answer for this indeterminate form is equal to 0. Kaya lang, meron tayo kasi sa umpisa ng ganito. Diba? So yung x raised to sine of x, yan ang 0. Okay? ln of x sine, ito. Yan ang 0. Kaya yung limit as x approaches 0 from the positive side, nagre-write tayo, di ba? Of x, yan, alam natin 0 yan. Kaya lang, nag-y tayo. So, meron na tayo ngayong 0. So, get the e of both sides. Y, therefore, is e to the 0. And the answer is 1. Okay? So, therefore, you could say now na yun palang limit as x approaches 0 from the positive side of x raised to sine of x is equal to 1. Okay? Yan siya, class. That's how you're going to solve indeterminate forms. Nag-incorporate na lahat ng natutunan nyo sa differential calculus doon sa midterm part itong topic na to.